Hi, Algebra 1. What you should have in front of you is your 214 activity note page. There's front and back on there. And what we're going to do is we're going to look at continuing on with our lines. Okay. Let's see. So what you need today is a pencil, your 3-ring binder, your activity note page that I just showed you, and just like in class, put your cell phone away. I know you're at home and I know that your cell phone is right next to you, but when you're working, especially on your schoolwork, especially in math, make sure that phone is silent, upside down, in the kitchen, in your mom's purse. Hide it. It's not helping you, it's only distracting you. So yes, put that cell phone away. It is a distraction. All right. Linear relationships. We've been working on this change in y divided by change in x. What's our growth pattern? What is our starting point? And today the question is, how are you going to find that slope if there is no graph? So when you were in class, either before this video or after this video, you looked at how do you find the slope if you have a graph. So what happens if we take the graph away? So let's go back to what we were doing. So we give you a picture and we ask you, what's the change in y? And so I will always put my change in y, in red. So when I go change in y, I'm just looking for how far down did I go. So it looks like I went down 1. Very important that you say you went down. You have to show me mathematically that you went down 1. So now let's look over and let's take a look at the change in x. So my change in x is right here. And it looks like I went over a positive 2. Okay. So there is my slope. And the question that we're really asking is then, what's the equation of this line? So my change in y, there are 2 things that you need to find that equation. And, we're going to talk a lot more about equations of lines, but remember, all you need for an equation is your m and your b. So your m is your starting point, or sorry, your m is your slope, which is your rate of change, and it's always going to be a fraction. It's your change in y, which tells you your distance vertically, divided by your change in x, which is how far you've gone horizontally. So vertical change divided by horizontal change. If I said that backwards earlier, I apologize. So my slope is -1/2. So one ingredient down. The second ingredient that you need is the starting point, meaning what happens, where is x equal to 0? And b is a coordinate point. It's when x equals 0, we are at 1. Our graph crosses at 1. So now my equation of my line is going to be this. You just put in your equation. So you just put it into y equals mx. So the m, or my growth rate, is -1/2. That's the number that goes before the x. Okay, -1/2 x plus or minus, depending on where I start, my 1. Okay, so there's that equation of my line. Y equals -1/2 x plus 1. All right, let's try something else. Let's really look and see what that y and x and the m and all of that mean. So again, I'm going to just write this out so we see it. Remember, our equation is y equals mx plus b. So what does the x and the y represent when we're using our tile patterns? Okay, so let's type in the x. So if you remember, the x represents that, where are you in your tile pattern? It represents the figure number, okay? Where are you? Are you in the first figure? Are you in the second figure? Like, where are you? The y represents then what? Yeah, how many tiles? Okay, how many tiles you have for a given figure number. So these are what we call variables. These are the things that are changing. If I am at figure 10, I could have 100 tiles. But if I'm at figure 5, I might have 50 tiles. Those are the pieces that are changing. So then what happens with this second question? Then what does the M and B represent in that equation? Well, those are what we call parameters. These never change. Variable means that it's varying, but a parameter never changes. So for that tile pattern, M and B are constant. So how do we look at this? Like, how do we understand what M and B are? Well, M is the growth rate, or how is our tile pattern changing? But in for tile patterns, it's the growth rate. What does the B represent? Well, just like we've been saying, B represents the starting point, otherwise known as figure 0. How many tiles are in figure 0? That's what B is. So M and B are parameters. They never change for a given problem, but X and Y are variables. They're the ones that are changing. So again, we need to ask the question, how does M and B affect the graph? So I'm going to come over here and let's take a look at, let's look at Desmos. So Desmos is y equals 2x plus 1. I want you guys to take a look at this. 2x plus 1. Our starting point is 1 and our slope is 2. Now I'm going to change that slope. So y equals negative, we'll do a half plus 1. Notice I started in the same place. Both of those lines go through the starting point of 1. But what happened to the blue line? It's not as steep. That slope changes how steep our line is. Okay, that's what slope does. All right, let's investigate what B does. So I'm going to start with that red line again, y equals 2x plus 1. But this time I'm going to say y equals 2x, same slope, minus 3. What happened to our line? It's the same slope, we have parallel lines, but now look at where we started. So the B changes where our graph starts. Is it going to start in the positive wise, or is it going to start in the negative wise? Okay, slope changes how steep it is. M or B changes where it starts. Okay, take a minute, answer that question C. All right, but here's the big piece of today's lesson. What happens if we don't give you a graph and we asked you to write the equation? How are you going to find slope? So can you find the slope if you're given a table? Well, what's slope again? Well, slope is just our, see here, remember, I'll put it up here. Slope is our change in y divided by our change in x. And I'm going to write that out in colors. I will always color code this for you guys. Change in y is red and change in x is blue. Always. So if you flip these, you know it's always going to be red over blue. So let's look for the red. So it says the change in y. So there's y, there's my output, and I'm looking for the pattern here. So if you started at -5 and went to 3, and you started at -3 and went to -1, and then you got to 1, what are we always changing by? You guessed it, or you got it, +2. Okay, so my change vertically, even though I can't see it on a graph, I can now see it in a table, is that +2. All right, let's take a look at this in the x direction, because you have to do the same thing in the x direction. Okay, so my change in x, what is going on with my change in x? Well, it looks like it's just a nice +1. So now I can say that my slope for this line is going to be my change in y, which is my red, plus 2 over 1. Now, make sure you're always reducing as much as you can. So 2 divided by 1 is 2. All right, let's try the next table. All right, I want you guys to try this table. See if you can find the slope for that table. Pause the video here and see if you can find it. All right, welcome back, guys. Hopefully that you found that this slope is you are subtracting 3. So your slope is a negative 3. So what about the equation for both of these guys? Now that you know the slope, could you write the equation? Well, sure. All we need to do is figure out where we start. Where's our 0 figure? So in each table, see if you can find out where that 0 figure is. Well, in table 1, there's the 0 figure. And in table 2, there's the 0 figure. So let's write these out. So for table 1, we would get y equals 2x minus 3. Let's write out for that second table. So we would get y equals negative 3x plus 5. All right. We got it, guys. Let's see if we can finish this off. It's okay. So what I want you to do now is what happens when you're trying to find the slope and we don't give you a table, we don't give you a graph, all we give you is 2 points. So let's see if you can figure this out. Well, let's try one together. My suggestion is always put these in a table. And you're just going to put your 2 points in the table. So my first point is 6, 5, and my second point is 3, 7. And guess what you're going to do? Yep, it's the same thing that you've always been doing. You're going to find that change in y, put it in red. 5 to 7 is you're going to add 2. And then you go find your change in x. So if I went from 6 to 3, that means I went down 3, so that's a negative 3. So when you write your slope for this guy, remember it's the change in y, so what you wrote in red, which is a positive 2, divided by a negative 3. Now we're going to accept that. I will tell you when you write this or if you type it into Canvas, it'll look a lot like this. It really doesn't matter what number has the negative as long as one of them does, but either one of those would work, okay? All right. Your challenge is to finish B. Let me get that out of your way. Okay. So put your points in a table and see if you can find the change in y over the change in x for part B, part C, and part D. Okay. Now, part D is not asking you to find the slope. It just says they found the slope to be 2. What was their error? See if you can find out what they did wrong. So when you're not given a table, create one. Put your 2 points in a table and see if you can find the slope, and then tell me what the error is. And finally, see if you can answer the slope challenge. What is the steepest line possible? And then what is the slope for the steepest line possible? We'll be discussing problem 5 and this slope challenge in class, so make sure you try it. We'll see you in class. Thank you, Algebra 1.